Okay, first I share my content there. Please reply to me. Can you see the screen? Can you see the screen? Please, hello.
Yes, we can.
Yes, all right. So if you can hear, so we start now our lecture, right? Where we stopped in last class, you can remember we were discussing about the, I think something about syllabus. Let's see the syllabus. We were discussing something about syllabus. Uh, something about syllabus. Uh, Perhaps I discussed about the CLO. CLO. It is important for your survey at the end of the semester. So I explained, I think, all the points, and then I explained. Did I explain the your exam? You remember? Hello. Anyone can hear me? All right. Anyway, so this syllabus are discussed, and I think you don't have any question, right? I assume you don't have any question. Yes. So now we start now chapter 1. We chapter 1 I start. There is a major disconnection sound in the just me. I don't know. So we are trying now to start our first chapter. First chapter is a introductory chapter with general principle, right? General principle. Okay. What is chapter objective? Chapter objective is basic quantities and idealization of the mechanics, Newton's law of the motion and gravitation, principle for applying the SI system, standard procedure for performing numerical calculation, and general guide for solving problem. So what we're going to learn here, what is the mechanics, what are the fundamental concept, what is the primary concept. We can say this the and unit of the measurement, the international system of unit, and the numerical calculation, general product procedure for analysis. Right, these are the chapter outline. So first okay, based on this outline, we will be discussing one by one. uh, Mechanics. Now mechanics can be divided in three branches, right? First is rigid body mechanics, then deformable body mechanics, and fluid mechanics. Now uh, first I tell you, I go from the bottom. Fluid mechanics. What is fluid mechanics? You know the meaning of fluid? Anyone? Anyone can answer me? Yes, liquid and gas. Someone said is correct. Liquid and gas. Fluid mechanics is a kind of liquid and gas. Liquid and gas. But in this course, actually, we will not discuss liquid and gas. So we are not studying this. Then deformable body. Can someone tell me what is deformable body, or what do you understand, or do you understand anything, something? Anyone? Body shape that has the ability to change the shape. Yes, flexible. Yes, yes. Homotrophy. Yes, yes. Is kind answer is kind of correct. Yes, something flexible or something. If you apply force, it get deformed. It get deformed. Right? It changes shape. So in our courses we are not discussing also this, but we have this is the first final one: rigid body mechanics, rigid body. Now, what what is mechanics? Very simple thing. Very simple. Can you know, or I can answer you in very simple word. What is mechanics? Mechanics is the stable. No, yeah, machineries. No. Mechanics is a branch of science where we discuss the effect of forces on a body or bodies. It's called mechanics, where the effect of force discussed, right? This mechanics. Now, what is the rigid body mechanics? So it is just opposite to the deformed body. When you apply the load or force on a body, it does not change its shape. It does not deform. It is rigid. It is stick. It is stick to its shape. It's called rigid body mechanics. Now, we actually will all the semester we will study the rigid body mechanics. The deformed body and fluid mechanics is not in our syllabus. We're not just going to discuss it. Maybe in third year or some second year you are going to learn fluid mechanics. This is not our courses. So mechanics has a three branch, and we will be discussing the first branch, right? Now the rigid body mechanics we are discussing again two parts. Rigid body, we will be discussing rigid body, and the rigid body mechanics again two parts. One is statics, another is dynamics. One is statics, another is dynamics. Now, anyone has an idea what does mean by statics and dynamics? What does it mean? Statics.
Doctor,
Sorry.
statics is the force on the body when it's stop. Uh, it cannot go away or something like that.
Yes. Something.
And
Yes. Someone
dynamics,
said
where is there is acceleration or velocity.
dynamics. You're talking about dynamics, right?
Yeah, dynamics when the force on the body when it's slow, go slowly or there is acceleration.
Yeah. Yes, you're correct. You are correct. Yes. So Abdullah Al Qasim said structure is the statics. Okay. Statics is we can say is that statics is when you apply force the rigid body is still in the rest position. It is not going to move. It is not going to move. There will no acceleration. And if there is acceleration, then this will be dynamics. So mechanics, first I tell you what is mechanics. So mechanics is the branch of the science where the effect of the force discussed, right? And then the mechanics is in three part: rigid body, deformed body, fluid mechanics. We are discussing the rigid body, and rigid body again two parts, right? Statics and dynamics. Statics is that part where the after application of the force, the body remain in rest position. It doesn't move. There is no acceleration. If there is acceleration after the application of force, then it is discussed as dynamics, or people say dynamics, right? Some people say it is dynamics. So when we say body in the rest position, that means body in the equilibrium. So statics, the answer I said you is here, right? Statics, the body is in equilibrium at rest position. There is no movement. Even if there is movement, move with constant velocity. Move with constant velocity. Acceleration is zero. So if acceleration is zero, then we say this is after application of the force. So there are two things can happen. One, body is at rest. Body is at rest. There is no movement. That means velocity is zero. Or if there is a velocity is zero, there is velocity zero. So if there is velocity zero, then no movement. But if there is some velocity but acceleration will be zero, then it will be said statics. If there is acceleration, then we will say this is dynamics. We will say this is dynamics. What is this? What is this? Someone send us some link. Okay, someone give me the okay, I will do it later on. Okay, anyway, someone send me the link. I will do it later on. I need to make a copy because my computer doesn't work. Just be wait for a moment. I keep it somewhere else. Otherwise, I'm going to lose it. Okay, come back. Where is my here, right? All right. So everyone clear? What is the difference between the statics and statics and dynamics? Everyone clear? Tell me, please. Okay, clear. Okay, everyone clear. So if it is clear, so acceleration 0 is the both rest constant velocity. Acceleration is 0 is in both rest and the constant velocity. So it is the only thing we need to determine that. Yes, if your acceleration is 0 or not, that's the we have to determine. If acceleration is 0, then we will say this is statics. If acceleration is not 0, then we will say it is dynamics. But don't worry about it that too much. Just today, just the introductory class. Here, we just giving the introduction. In this course, we will always be discussing statistics. We will be always discussing statistics, not dynamics. Dynamics is the next another course. Maybe you have completed or you will be completing in next semester. All right, next slide. It goes. So basic quantities. We'll be learning what are the some fundamental concept. I think you already know those concepts. You already know those concepts. But why I am why just refreshing your memory. You already learned this one from physics or in the school, high school. Basic quantities. What are the basic quantities? Length, right? For everything we measure, we need to know the length, like locate the position of a point in a space. So by an example, the distance between you and me. Maybe you are somewhere sitting here, someone sitting at your home, maybe 5 kilometer, maybe 10 kilometer later on. So this is the kind of the length. Or you may have gone to the some shop where you are buying the cloth. So where cloth you buy the 1 meter cloth or half meter or 2 meter cloth. So this is the based on the length. So this is the basic quantity. Another one is mass. Another is mass. Mass is the measure of the quantity of matter. Quantity of matter. So here is I have one question to you, and I will explain, or you will answer me. Mass is the quantity of matter. As example, how much mass in a body, right? How much mass in a body? So can you someone tell me example of mass in real world? 5 kg. Fine. It is mass or weight? Tell me. Kavala, stop. It is mass of weight. Then what is weight? When you go to shop, do you say them give me 5 kg mass of rice, or you say give me 5 kg ozen or weight of rice? Okay, Hussain is saying that mass into weight. Okay, fine, clear. That's good. So there's difference between the mass actually real quantity in the body is mass. how much real quantity mass, and the effect of the gravity. When you consider effect of the gravity, then it convert to the weight. Okay, time is the real thing. Time is the one thing. Succession of event, when some event happened. As example, time is our class started at 9:30. Our class will be ending at gravity and mass is weight. Gravity, no, Abdul Khalid, Hussein was correct. Mass into 9.8 is the weight. He was the correct, right? The Abdul Khalid is no, it's not correct. So force, right? Now time is some happenings or something at some point of time, right? Some point. And now force. Now force is always only two type. Force type is two type. You are going to push or pull. That's it. You are going to push somebody, push or pull. So a push or pull exerted by the one body on another. Now this force push and pull, it is the kind of the general word. General people speak like this: push or pull. If you go to the bakala, like the grocery shop, you will find the in their door it's written push or pull, right? General people is talking like this. But we are engineer. You are going to be the engineer. At the end of the or the middle of the semester, we will tell you the new terminology of defining force. In that case, push usually we say compressive force, and pull we say tensile force, right? This force will have different name, different name, and I will teach you. Sometime we will say this is the concentrated load, concentrated force. Sometime inclined force. Sometime we will say distributed force. Sometime compressive force. Sometime tensile force. Different name. There will be the different name of the force depending on the application, depending on the situation. But in general, always force is two type. Only there could be two type. Only push or pull. Now fundamental questions is idealization. Now particle, right? Can someone tell me? It is written already there. It is written, but still, can you tell me what is the particle? What is particle? What do you mean by particle? Maybe last class we already little bit discussed about it. Two small parts. Yes, yes, right, correct. Kawan Ashraf said two small parts. Very small, very tiny things. But your definition, academic definition in books is something has mass but there is no size. It's called particle. This kind of thing to have is very impossible. But when something has mass but there is no size, if there is no size, how can be it has mass? It's kind of thing, imaginary thing, that the particle is so small, it doesn't have size, but we imagine that it has some mass. So particle definition, you see, has a mass and size can be neglected. Size can be neglected. We assume size is very small, but there is a mass. It's called particle. Now combination of number of particle makes rigid body. A combination of yes. Atom. It is the terminology of chemistry, right? Similar, almost similar. When we meaning, atom is something. Something the chemistry people, they say something the smallest part of the body. In mechanics, we will say particle is the smallest part of rigid body. Then what is the rigid body? But we don't need to be very much worried about these things. When we'll be talking about that, we just know the particle is the very small thing, and rigid body is the combination of the large number of particle. Maybe 1,000 or million, billion particle makes a rigid body. That's it. Right? We don't need to be very worried. Like a combination of large number of particle, right? is called rigid body, but condition is there will be no deformation. There will be no deformation. Okay, so we learned particle, we now learned rigid body. Now concentrated force. Concentrated force. Just one slide before I told you this force will have different name in different position. Now here is the one example, concentrated force. What is concentrated force? Load, and now again I think load. Force is same thing as force is sometime not sometime. When you are the engineer in future, always will be talking about load. Force will not talking about the force, right? Will be, instead of force we'll be talking load. Can someone hear before the word load? Did anyone hear the word load before? Yes, can example, one example. Wait for loading. Yeah, wait for loading. It's kind of the loading of truck or unloading of truck. This is the verb, something verb. No, like we can say that in a building, as example, in a building, there are lots of heavy machine. Load something. That is verb. Load something or loading and unloading. This is the actually verb. This is used as a verb. Verb. This is used as a verb, right? But load is in engineering, like example, the building, one building, right? In building, what we have? Concrete, right? We have slab, we have column, very big building. We have slab column. So building has self weight, right? Self weight. It has own weight. So we say the self load, or in building we have chair, table, we have table, we have machines, we have computer, lots of things, right? This we say this is also kind of the load, which have the weight, which is applying that force, right? Of course. All right. So sometime in engineering, force, instead of force we say load. Okay, so load assumed to act at a point on a body. If our load is work at a one point, then we say this is the concentrated load. As example, if I have here something, can I tell you shape, right? Suppose we have, this is our suppose this is our something floor or roof or slab, right? Floor, roof or slab. Now some force is working at just exactly at one point, some force. Then we will say this force is a concentrated force. This force is concentrated force. So this concentrated force, right? Then now we come to the very important some law, Newton's three law of motion. Newton's three law of motion. That is very important for us for this statistics course, and actually we will be depending on these three law. I think you already know the three laws, Newton three laws, right? First law: a particle, it originally at rest or moving in a straight line with constant velocity, will remain in this state provided that it is not subject to an unbalanced force. Okay, anyone understand this thing, what it is saying? Can you tell me what is the meaning of it? Anyone please? No answer? For first law, Newton first law. Hello, can you hear me? Are you hearing me?
Yes, doctor. Repeat the question, please.
Yeah, I asked you the just on your own word. Tell me the first law of Newton, law of motion. Someone
It's
said
written. It's
it's
written,
written.
doctor.
It's written, but you tell me without written. Suppose I
Yes,
remove
doctor.
it. I remove it, right? Newton first law. Yes, x into space. What is it again?
Everything is in rest. It will still in rest if there is no force effect on it, and
Someone,
also the movement thing.
yeah, he said, someone said, yeah, I can see, means no change will happen on the particle if there is no force on it. Yes, like something will be remaining on rest position, on its position, anti Yamal Kiawa, right? Newton said, if there is no external force, it will remain forever its same position if there is no external force is applied, or something is moving, it will be keep moving. It will be keep moving at a constant velocity if there is no force is applied, right? This seems very simple, right? This seems very simple formula, very simple law of motion, but it's very significant. It's very important. It's very important. Without this, we cannot do anything. We cannot learn anything in statistics. We said, or the speed of the no change. Yes, the speed no change. Abdul Khalid is said correct. Abdul Malik Khalid is correct. All the forces cancel each other. Maybe that is we learn. Yes, it could be, but we learn later on. Like no, Newton's second law. Newton's second law. What is it? The final result of force is zero. Yes, correct. If zero, then it is statics. But sometimes there could be no final result is no zero. Then it is dynamics. The body will start to move with acceleration. Uh, Now, so Newton's second law: a particle acted upon by the unbalanced force experiences an acceleration a that has the same direction as the force and magnitude, that is directly proportional to the force. Directly proportional to the force. What is saying there? Can anyone explain me? It is written there, but can anyone explain me? Second law. No answer. If there is a force, there is acceleration. If there is a force, there is acceleration. The force will be the same direction as the acceleration. Yes, that in there, yes, correct. Same direction as the force and magnitude. Okay. So you said the force will be same direction, that's right. What about magnitude? What about the magnitude? So very simple here, reading there. A force, the object will move if there is force acting on it. Yes. Here is written there. So the direction will be same direction of the acceleration a, and magnitude will be proportional to the force here. So magnitude F, force will be proportional to the acceleration. M is the mass is the constant here, because mass is constant here. Then F equal to ma. It is Newton's second formula. What is saying this Newton's second formula is the magnitude of the force is equal to the uh, is saying that the same direction and magnitude is directly proportional to the force. If there is the force is more, then acceleration will be also more. If acceleration force is, acceleration will be also less. That is the meaning here telling, right? So Newton's second law of formula. Now you tell me Newton third law of formula. Newton third law of motion. Newton third law of motion. Can you tell me Newton's third law of motion? Like when some wall, then if you cannot, if it's difficult for your writing, you can speak, because voice chat is allowed here. I keep the voice chat on. You can keep speaking. It's just like when one will push him. Did you see any time That wall is pushing you. You push wall and wall is pushing you. Did you see sometime? And
If you apply a force on something, something will apply the same force with another direction, the opposite
opposite
direction.
action reaction. Yes. Yes. Very simple. Third law is very simple, right? Can someone tell me just in one sentence? It is very simple. Yes, very simple. I tell you, every action has opposite and equal reaction. Very simple, right? Third law is like this. Every action has two things, equal and opposite. There is two conditions. The reaction will be equal and it will be in opposite direction, not the same direction. Not
After
the
equal magnitude,
yes, equal magnitude.
and opposite direction.
Yes. Remember, I'm telling you today, all the semester I will be discussing this. A force, when you apply a force, there will be two things always. One, it will have magnitude and it will have
Direction.
direction. Yes, that's these two things we will always be discussing in this course. It will have magnitude and it will be work in a definite direction. When I give you when we will do some example, we calculation some example, or in an exam I will be always asking that tell me the direction and magnitude of the force, right? Force, momentum, whatever. So this is one important thing you always remember. The force has to be defined by its magnitude and direction, right? So Newton's third law is, I repeat, every action has equal and opposite, equal magnitude and opposite
Direction.
direction. So direction. See there. Third law, the mutual forces of action reaction between two particles are equal and opposite. Another thing, I forgot to tell you this one. This is also important. Three things very important. It has to be equal. Force has to be equal. Force has to be the opposite, and force will be collinear. Do you understand meaning of collinear? Can you tell me collinear?
In the same opposite direction, but linear
Collinear means
direction.
someone said no, you don't understand, but it is very simple. Collinear means same line. It's same line. In picture you can see it's simple, very simple. Like if force working on a body A, yes, same line, a body. So reaction will be from body B in opposite direction, and the same amount, same magnitude,
Or
same line,
or better,
Yes.
can we say in the same axis? Maybe
Same
if
axis,
it's
yes, yes.
in the x-axis, it will be in the minus or plus, but it
In opposite,
cannot
yes.
go to the y-axis.
No, cannot go y-axis. You
Yeah,
can say same axis, but it is not always will be the axis. So we can say collinear. I show you an example, right?
yeah.
I
We cannot so you cannot say it's in the same axis because sometimes it's become an angle or something like
angle
that.
like this force. Okay, I have drawn it, right? I have drawn it one angle. So some force is working. Now opposite force cannot be opposite force. Opposite angle has to be like this. Completely, it will say it will be said collinear. Some force is here and opposite force and the reaction force. Suppose this is the action force and reaction force will be equal amount and opposite direction and same line. It cannot be like this. Okay, it cannot be like. Finally there, finally there are one line. They are in one line as per the Newton third law from. So this is here. So this is the collinear. Now if I remove it, if I move it, okay, it must have to be always like this. That must not be right. It has to be the collinear, right? It cannot be like this. It cannot be like this. So condition is it has to be, force has to be equal amount, equal magnitude, opposite direction, and collinear. This is, you remember always, this is the Newton third law of motion. Clear? All right. Any question? No question. If there is no question, I go to the next slide. Now Newton's law of gravitational acceleration. Newton gravitational acceleration. I also assume that you already know this from the physics you have learned, right? If there is force, if there is a force gravitation between two particles, g is the universal quantity. If there is two particles in the universe or on the earth, like you and me, you have some mass or some you come your book and your book or your table, right? There is a mass, there is mass m1 m2, right? And if there is a distance, so the attraction force between them equal to this formula, F equal to g m1 into r divided by r square. So F is proportional to the mass of the body, mass of the two body, and inversely proportional to the distance. Inversely, so m is the mass of the two particle, distance between the two particle. That means if the distance is less, so mass, the attraction force will be high. Attraction force will be high. So, and weight. What is weight? If we have two body, we have two body, right? If one of them is Earth itself, then we put m the force weight of Earth, then we will get weight of the body. So W equal to, in that sense, m into g. Can you tell me the W weight equal to m into g? Here g, what is the name of the small g?
Gravity.
Sorry?
Gravity. Equal
Gravity.
9.8.
Yeah, I know gravity, but yes, 9.8. What is the unit? Unit. ms square. Abdul Khalid said. What ms square? Can you tell me? ms in meter per second square, right? Meter per second square. Gravity. More clearly, yes. Abdul Rahman has written correctly. Abdul Rahman, meter per second is wrong. Who said per is wrong? This is wrong. Meter per second square. And someone said its gravity is half correct. It is acceleration, gravitational acceleration. Its name, gravitational acceleration. And someone said this is the 9.8. Okay, 9.8, fine. 9.8, it's fine. Okay, so W equal to mg. If I write down W equal something like ma, then what will happen? What we will get? Can you tell me? Instead of G, if I write A, what will happen? No answer? Very simple. We just learned in the previous slide. Equal to F. Or we learned F equal to MA. We learned F equal to MA. What's equal to mass into acceleration? Right? Now, if A equal to G, then F become W. That's I want to tell you. Then F become W. Then we have to write M into G. All right. So force equal to mass into acceleration. If this acceleration is gravitational acceleration, that means we got the weight of a body. Clear? Okay. It should be clear because it is very important. Because I know from my previous experience, at the middle of the semester when you will be doing some example or practice, some student become confused between the m, mass, and weight. Sometimes you need to multiply by the 9.8. Sometimes you need to divide by the 9.8. Sometimes you don't need to do anything. So you become confused. What is this? That's why I make you clear. When we say weight, that means when we say weight W, that means mg, right? When we say W mg. When we say mass of body, then remember, then I am talking into MA. Remember, okay? Remember this thing. It's very important. Very small and minor things, but very important thing. Only doing mistake here, you do the lot of mistake in the exam, and you lost lots of marks. So be careful from now, okay? So now, so that's why I'm telling you W equal to mg, right? Originally it was F equal to ma. All right. How? How? If I tell you, if A equal to G, if A equal to G, then F become W, then F become W. All right. Who asked the question? Who asked the question? I write it for you again, right? I write down for you here. Maybe you can write. I don't know. No, I cannot write. So I write somewhere else. I write somewhere else. If I have the space, I write somewhere else. Yes, yes. Abdul Khalik give the right answer. Yes, they have the same unit also. Yes. So I write down here for someone has asked question how W equal to F. Like, look, this is the formula, right? What's happening? I don't want this. What is happening? Just please wait. Equal to MA. So some student, I don't know his name, he asked me questions. I need to make him clear. What have weight have no direction and the force have the direction? You are wrong. ID number this ID number 848. You are wrong. You are wrong. ID this ID. You are wrong. You said weight has no direction. Completely wrong. Weight has direction. Weight has always direction. WEAI. Weight has direction. Weight always work downward. Always. Weight always work downward. It has direction. All right. Clear? I cannot see your name. This student, I cannot see your name, but I see your ID number, so I make you clear. All right. Yes. Well, weight always has direction. W equal to 8. Now, if here F equal to ma, if acceleration equal to, we assume like acceleration, you can assume acceleration value is, you can assume acceleration is equal to 3.2 meter per second square, 2 meter per second square, right? You can assume A equal to 10.2 meter per second square, whatever, 2%. But if when your acceleration become 9.8 meter per square, then acceleration A, its meanings actually it become G. It become G. That means A become G. That means this A become G. When this A become G, then we can write down easily it is W, weight of the mass, right? Just in the next slide we will be discussing this. Okay, next slide we will be discussing this. Clear? All right. Okay, now unit, right? SI unit. In this course we will be learning SI unit, but I also encourage you to always learn different unit like British unit, metric unit. You should have idea of different unit, because when you will be engineer, then you may need to deal with different kind of units, right? SI stand for International System of Unit. SI system specify length in meter, right? Time in the second, and mass in kilogram. But as I told you, another thing just to inform you, the British unit system, length is feet, length they say feet, time is second is fine, and the mass is they say in pound, mass is pound, right? And here mass is pound, and force unit is Newton. Force unit is Newton in the SI system. Now,
Doctor,
yes.
what about the units in the book? Do we have to convert it to an SI unit?
It will be the SI unit. If sometime it could be happen the no, there's two answer. If SI unit, you do directly in SI unit. If it is different other unit, you do different. If other unit, you do that on that unit, right?
Okay, no problem.
Right, until you complete that unit. But I will try to follow the SI unit. Okay. So international unit is the length is the meter in second, time per second, kilogram kg, and force the Newton, right? Force is the Newton. Now, at a standard location, as you already know, G equal to 9.8 meter per second. For just for the calculation, we use 9.81. So, as example, just I told you, W equal to mg. Hence, a body mass at 1 kilogram. So, just I showed you, right? A body mass has 1 kilogram. Its weight is 9.8 Newton. When we say 1 kg mass, 1 kg mass, that means actually weight is 9.8 Newton. If we say it is 2 kg of body, then his weight is 19.86. Clear this one? Clear this one? Clear to everyone?
Yes, yes, Professor.
Okay, okay. All right. Now some prefix. Yes, okay, fine. Some prefix for a very large or a small Newton quantity unit can be modified by the using the prefix. I think you already know, but as example, each represent multiple or sub-multiple of a unit. Like example, this is a very long number and it is very difficult to write. So what we do usually four we can write down for this three zero we can write kilo k. So 4,000 and kilo we can write kilonewton. If it is 6 number, then we say mega. So 4 equal to mega Newton, right? If it is decimal number 0.000, then we can write millimeter. And then this is the conversion multiple and the sub multiple. Like if it is the 1,000, then we write kilo. If it is the after one, then 660, then we say mega. If it is the 90, we say giga. You should already aware of this, right? Because when you buy the mobile data, you know the what is megabyte, what is gigabyte. You should be very clear. I think every people know this. Submultiple, if it is the 3 digit, then we 10 to the minus 3, we say it's a milli, like millimeter. If it is the 6 digit, then we say micro. If it is the 9 digit, then we say nanometer, right? Nano or something nanometer. And we can write for make to make it easy for writing the numbers, so we use this multiple and submultiple. All right, so today time is finished. Maybe we have a little bit or 5 slide. Maybe we'll start in next class. All right, you have any question?
No, thank you, Doctor.
No,
Thank you very
thank you.
much. Thank you very much. See you in the next class. Okay.
So,
Next,
so
please. Any question? Yes.
for the
Okay, thank you,
exams,
Doctor.
is it all numerical or there is another type of questions?
I think all numerical.
Okay, thank you.
Okay, all of you are welcome. Thank you very much. See you in the next class. Okay.